Hi, and welcome to this FreeRTOS preference. I'm Norman McIntyre. Let's get started. So the textbook reference for this will be following Mastering the FreeRTOS Real-Time Kernel by Richard Berry, and I'll be covering the preface. So the thing, you can watch the slides and you can also refer back to your textbook and read for additional information. What I've done in the slides is pull out the highlights from this section. So we're going to talk about the FreeRTOS, talk about the value proposition, give a few notes about terminology, ask why you'd want to use a real-time kernel, and look at some of the key features that you'll be learning as you go through this course. So about FreeRTOS, it is aimed at embedded real-time microcomputer-based applications, which are, as you know, covering the world. Billions of these devices are out there all over the place. The current version is 10.1.1, and these applications include really two types of real-time. So when you think about real-time, I would say divided into two different types. You can have soft real-time requirements, and we can have hard real-time requirements. FreeRTOS covers them both, but let's see what each one involves. First, the soft real-time requirements. That means you've got to do something within a given time, but if you don't quite make it, if you breach the deadline, it does not render the system useless. And probably the best example of this, we've all seen it when we're using systems. Maybe the keystroke is responding a little too slowly. For example, you drive up to the gas pump and you're in a hurry to pump your gas and you're punching on the keypad, a great example of an embedded RTOS system, and you're typing on the keypad and maybe the keypad is not responding fast enough for you because you're in a hurry. Well, that doesn't render the system useless. You just have to slow down a little bit, maybe touch the key twice. So soft real-time is not a showstopper if you don't handle that requirement in time. On the other hand, a hard real-time requirement, you've got a definite deadline that must be handled, and there's no option to miss it. So if you breach the deadline in this case, then your system has become totally useless. An example, right? The airbag deploys too late. Well, if you've got an embedded system in your automobile, which by the way, there's probably, probably 50 or more embedded systems within an automobile, these modern automobiles. They're just spread throughout the system. And so maybe you've got one that's handling the airbag, and if it deploys too late, well, that's no good. So hard real-time, we'll see in this FreeRTOS, you can, through setting priorities, you can absolutely ensure that, for example, if the airbag needs to deploy, that would indeed happen. So, as I mentioned, it handles both of these, both the soft and the hard real-time. It organizes applications as a collection of independent tasks. And this is going to be a key thing. We're going to find that when we put our FreeRTOS apps together, each one's an independent task, and you may have 2, 3, 4, 10, 20, however many tasks. The higher priority tasks are dedicated to hard real-time requirements. And we'll find that the way the FreeRTOS scheduler runs, higher priority tasks always run before lower priority tasks. So you'll never ever have to worry about a lower priority keeping a higher priority from running. So at the high level, at our first look at this, we can say, well, the high priority task will be dedicated to hard real-time, and the lower priority task will be dedicated to soft real-time. And of course, as we go through here, we'll learn how you set the priorities and also how you create these tasks. So what's some of the value proposition? Why has FreeRTOS become such an industry leader? Well, it is professionally developed. So from day one, the team said we're going to only develop professional code, which means we're going to have strict quality control. Probably the thing that surprised everyone, they kind of saw ahead, just like the folks who did Linux, they kind of saw the future before the industry in general. And they said, you know what, we're going to make it free and open source, so a company can totally get this and use it any way they want to. They can modify it, they can change it. They don't have to pay us a penny. On the other hand, they also give you the option, if a company does want support and does want to have an official license, you can do that as well. So it's the best of both worlds, and this is certainly one of the reasons it's become so popular. Another reason, of course, as most embedded software, it's written in portable C. So this C will basically can be put on any type of microprocessor. The kernel is very, very small. In fact, there's only 3 C source files that are needed in a bare minimum. And so it's very easy, right? You say, well, I'm going to learn all about those 3 files, and you'd know everything about FreeRTOS. It also has a very small memory footprint. And of course, we know in embedded systems, small footprint is important. So a small footprint, low overhead, and it's very fast, right? It's important that all this stuff runs fast, efficiently, and FreeRTOS does. So we've mentioned about the concept of a task. FreeRTOS does use this term called a task, which is just a thread of execution. In fact, in some other environments, you may talk about threads, but they decided to call the task here as a thread of execution. And as we said, you'll organize your solution that you're working on into a set of tasks. For example, maybe part of your solution is it flashes an LED every second. Well, you might just have a separate task that does nothing but that, just flashes the LED. And so the nice thing, you can say that task is in charge of flashing the LED. Maybe you have another task who its only purpose is to read from, say, an analog to digital converter. So we're going to learn much more about creating tasks. That'll actually be a full lesson focused just on task coming later in this course. Some of the features, again, I want to stress, it is open source. It has an MIT license, which says you can basically use this however you want to and make changes to it. Has static and dynamic memory allocation. Typically we'll use dynamic. That means we allocate the memory as we need it, but if you want to just do everything statically, and you can do that as well. Of course, we'll have tasks where we assign priorities to those tasks. We'll also have software timers. Software timers, we can have a one-shot timer that has a timeout, or we can have a periodic timer that basically every so often it fires the timer again. We can have queues for communicating between tasks. We can actually send messages through these queues. And of course, synchronization is a key thing. We have various synchronization options. We can use a semaphore, both a binary semaphore, which is basically a 1 or a 0, and also a counting semaphore that keeps a count of how many times you've incremented, say, the semaphore, and a mutex to provide mutual exclusion. All of this list of features, you can think of, we're going to have a set of functions we can call for each one of these, and that will allow us to perform the various features here. Last, there's a tickless mode for low power. That is, if very low power is important, you like to turn off the clock as often as you can, and there's a tickless mode for that. The licenses, as I mentioned, this can be used in commercial applications. Also, it's freely available to everybody, so you can grab everything we talk about in this course. You can use in your own product. You retain your own IP, that is your intellectual property. You don't have to share it. You can keep it to yourself. There's all kinds of versions you can license. The one we're going to use is FreeRTOS, which is the free license. But as I mentioned, a lot of companies will feel a little uncomfortable having just totally free license. So what they'll do is get a commercial license. Commercial license gives them more official support, and also it satisfies the legal department in some companies. There's also a safe RTOS, which is one that's been put through some tests for safety critical implementations. Again, all of these have the same features, but it's basically how it's licensed and also where the additional tests are run. And last, there's within the last few years, the Amazon FreeRTOS, and it just adds some libraries. And by adding these libraries, you pick up the IoT support in AWS. So the IoT, the Internet of Things, you can now have your device connect to AWS or Amazon Web Services. As far as architecture supported, wow, I mean, look at this. This pretty much says why it's the market leader. There are over 30 architectures supported. I mean, pretty much everybody who makes a microprocessor is on here. You know, just we look at Atmel and Cypress and IBM and Intel and Microchip and NXP, just tons of them. And the one I have highlighted here, ST Microelectronics, is the one we'll be using, the STM32. So what's great for you, once you learn one of these, because the FreeRTOS API is so portable, you can basically run the same code that we'll be talking about. You can run on any of these. So the API will stay the same independent of which one of these processors you're working on. So why do we want to use it? Well, we can create multiple tasks with different priorities. We can abstract away the timing info. We can say, hey, just let RTOS handle the timing details. It is maintainable, it's extensible. Again, they handle the details. We have the modularity, each task totally separate. Team development, within a team, each member of the team can have a well-defined module that they work on, and there's well-defined interfaces. Gives us easier testing, right? Again, with these well-defined modules and interfaces. We have code reuse. We can reuse in multiple projects the same foundation. Of course, improved efficiency because the software is event-driven. And there's an idle time scheduler. Basically, there's we'll find out the scheduler has in the background a daemon running that provides idle time. It has power management. So if low power, which typically is important these days, particularly for battery devices, and also flexible interrupt scheduling. So again, there'll be this daemon task that's running, and you can do things on it. And if all that was not enough, guess what? If you just want to try it out and you don't actually have hardware yet, there's actually a FreeRTOS port to Windows. And this is useful for learning this FreeRTOS API. It's not really real time on Windows, but for for learning the concepts, it still works fine. It's real time enough. And then, of course, when you run it on real hardware, you'll be familiar with the APIs. The Windows version is built using a express version of Visual Studio. That is, you don't have to pay anything. You can download the free-to-use Visual Studio and run the simulator on that.